Good morning, all. My name is Angeeta Hirve, working in computer science department as an associate professor. Today I will teach combinational circuit. It is a part of digital electronics. So we will discuss about the combinational circuit. So combinational circuit is a circuit combinational circuit is a circuit which made up of logic gates and which perform logic gates and which perform specific task. So here as I told, combinational circuit is a circuit which made up with the logic gates and which perform a particular task. So here we can also define the combinational circuit. Combinational circuit is a circuit which have the n input or n input variable and n output variable. So whenever we will talk about the block diagram of combinational circuits, so here we can take, these are the n input variable n input variables and these are the m output variables. M output variables. So here this will be the combinational circuit. Now when we categorize the combinational circuit or types of combinational circuit, so combinational circuits are many more like half adder, full adder, multiplexer, demultiplexer and so on. So here we will discuss one combinational circuit, that is multiplexer. First of all, I will write some examples or types of combinational circuit. Circuits. So this is, first one is half adder and full adder. Half subtractor and full subtractor. Multiplexer, demultiplexer, decoder, encoder, etc. So these are some examples of combinational circuits. Here we will discuss one combinational circuit, that is multiplexer. So first we will talk about the multiplexer. So multiplexer is also known as mux. So multiplexer is again a combinational circuit which have 2 raised to the power n input and single output. So here we can say a multiplexer which have 2 raised to the power n inputs, these are my inputs, and single output. Now which input will be selected by the output side? So which is decided by, this is called mux, and here this is the type of 4 raised to 1 mux or 4 cross 1 mux. So these two are the A and B are the selecting variable. Lines are variable, you can say. So here selecting lines or control lines. Selecting lines are control lines. So here there is a multiple input lines, which here in which input line input is decided, it is inside the output. The decision will be taken by the selecting variable. Selecting variable or control variable will decide which input will be go at the output side. Suppose here we can take the example. So suppose here we have 2 inputs, like these are the selecting variable, my selecting variables, and y is the output. Here we can say this is the y. Now here we give the combination of inputs. So the first combination will be 0 0, 0 1, 1 0 and 1 1. So it will be in decimal. So here we can write the number, or suppose this is the decimal of 0, 1, 2 and 3. So what will happen? Suppose these are my input I0, I1, I2 and I3. So whenever input is here, whenever this combination has the 0 0, A and B lines will be 0 0. So in 0 0, when the A and B will be 0 0, here the I0 will be select. When it is 0 1, so I1 will be select. When it is 1 0, so I2 will be select, and 1 1, I3 will be select. So this is the truth table of multiplexer, we can say. So what will be the output? So output will be, here we can write, this is AB or AB I0, A bar B bar I0 plus A bar B I1 plus A B bar I2 plus A B I3. So this will be my equation, output equation we can say, and this will be the truth table. So multiplexer is also known as data selector. Why we call it as a data selector? Because it will select the multiple input from which input will be go outside, which is decided by the selecting variable. That's why we also called as a data selector. Data selector. So this is about the multiplexer. Through this concept, now how will design the circuit diagram? So here, as I told, this is again a combinational circuit. So combinational circuit is made up with the logic gates. So here we can see, this is here in truth table we can see here A and B, the combination of A and B is deciding the output of I0, I1, I2 and so on. So here we will take 4 NAND gates. And the input is, here I am taking the direct input, that is A, this this is the very easiest way to design. This will be the A bar. This is B and B bar. So, here the first here we will give the input. This is the connected to 0 0. Here we can use the jumper when we design the circuit diagram. Here I am putting this dot. So, this is A bar B bar, A bar B, A bar B, A B bar and A B. And here we give the input I1, sorry, I0, I1, I2 and I3. So, here we got the output. Here we will use one OR gate to get the single output. So, this will be the Y. So, here we get whatever the combination will be over here. So, here we get the I0, I1, I2 and I3. According to this equation, we get the output. So, this is called the circuit diagram of multiplexer, 2⁴1 multiplexer, or you can say mux. This is 4:1 mux. So, this is all about the 4:1 mux, through which we can design the 2:1 mux. Whenever we design the 2:1 mux, so it will be a 2 input and 1 single output and 1 selecting variable. If it is 8:1, so the output will be this is 2:n, means n, the value of n will be n is the selecting variable. Here it will be the n. So, when the value will be n equal to 3, so selecting input will be 8. When n equal to 4, so selecting variable n equal to 4, so it will be 16 and the output will be 1. So, this is all about the multiplexer. Now, demultiplexer is the vice versa of multiplexer. So, how we can understand the multiplexer in the real life, or you can say application of multiplexer. So, first we will see the application also. So, when we talk about the application of multiplexer, so application of multiplexer is, suppose we have 4 signals and 4 signals which we want to transmit at the transmitter side. So, suppose T1, T2, T3 and T4. These are the different transmitter, and R1, R2, R3 and R4. These are the receiver. So, by the T1 I will send the data on R1, via T2 I will send the data on T2, T3 and so on. So, what I will do, I will send the data from transmitter side to receiver side. So, how I will send the data? So, this is, suppose this is my mux. So, here I will take 4 inputs. This is T1, T2, T3 or T4. So, output will be single. Here there will be a 2 selecting variable which will decide. So, here we get the data in a single line, and at the receiver end we got the output, and at the receiving end what we will use? We will use the demux. So, here it will be the demux. So when the T1 when the select here the cells, when the selecting variable will select the combination 0 0, so in this line the 0 0 will be available. When the combination will be 0 1, so T2 will be available at the output side. When the combination will be 1 0, so then T3 will be available, and when the combination will be 1 1, so T4 will be available. So through this we can decide. Similarly, whatever output is coming inside, so according to this selecting variable, these are here you can say this is the control variable or selecting variable, control lines or selecting line, you can say any the control lines. So here the control line will decide which input, which output from for the demux, this will be the input, and according to this combination, suppose here the combination will be 0 1, so output will be at the this side like R1, and if it is 1 1, so here we will get the R3 like this. So this is the example we can use in the multiplexer. This is very important combinational circuit which is used in the communication side. Now second one is the demultiplexer. Demultiplexer. So demultiplexer is a vice versa of multiplexer. So in demultiplexer, it is the definition of demultiplexer, we can say it is again a combinational circuit which have one input and multiple input and n selecting variable, or a single input 2 raised to the power n output and n selecting variable. So here again we are talking about the 1 cross 4 mux. So here it will be the single input, multiple output, these are the outputs, and this is the control line or selecting lines. Fine. Suppose here I am taking the value S0 and S1, or I can take AB also, it's depend on us, we can take anything. Fine. So here this is a demultiplexer, we can say block diagram of demultiplexer. Whenever we will talk about the truth table of multiplexer, so again we will, here the selecting variable will decide here output is coming, multiple output single output is coming, but single output will be go in which output, which is decided by the selecting variables. So here the truth table will be so here we can take, like here I am writing the value like I0, I1, I2 and I3. So when it is 0 0, 0 1, 1 0 and 1 1. So when the combination will be 0 0, I1 will be high and remaining we get the 0. When it is 0 1, I1 will be, we get the output at the in the I1 side, and when it is 1 0, so it will be 0 0 1 0, and if it is 1 1, so we get the 0 0 1. So this is the combination for the this selecting variable. When it is 0 0, I1 will be selected. I1 means here I am writing the name of output is like this is I0, I1, I2, I3. These are the output. Fine. So how here we can see the again the multiplexer have the we have the 4 combinations. So here we need 4 NAND gates. Now the circuit diagram. Suppose this is A, this is A bar, this is B, A bar, this is B and B bar. Now it is connected to 0 0, 0 1, 0 1, 1 0 and 1 1. Here we get the I0, I1, I2 and I3. Now there will be a single input. So here we give the one input like E. The name is E, which will be connected to all 4 AND gates. So whenever the combination of E, here we are taking, we can take E also, right? So E will be high, all the time E will be high. So E will be high, so it's depend on the combination of A and B. When it will be 0 0 1, so 0 0 1, so it will be here when I am applying the 0, here will be, it will be complemented to 1. Here I am at the B side I am applying 1, sorry 0, so here it will be B, so 0 0, oh sorry 1 1 1. So only I will get the output at the I1 I0 side and so on. So this is the circuit diagram of multiplexer, and multiplexer is very much similar to the decoder. Now third one is decoder. So when we will talk about the decoder, decoder is categorized on a different types like 2⁴ decoder, 3⁸ decoder, 4�16 decoder, 2⁴ decoder is also there, sorry 1⁴ decoder is also there, and so on, 5�32 decoder and all. So again we can say decoder is a combinational circuit which have 2⁴n input and 2⁴n output. Decoder is a combinational circuit which have n input and 2⁴n output. Suppose the value of n will be 2, so n will be 2, so 2⁴2 means 4, so 2 input 4 output. When the value will be n equal to 3, so 3 inputs 8 outputs and so on. So we can find out the value of decoder. So this is, suppose I am writing over here, this is my 2⁴ decoder. Here I have the 4 outputs, right? So this is 2⁴ decoder, right? So how I will design the 2⁴ decoder? So suppose I have 2 input A and B, and here these are my inputs and outputs. Suppose I have the output, the name is D0, D1, D2 and D3. These are my outputs. So again the combination will be in decimal. Suppose 0, 1, 2 and 3. So the combination will be 0 0. So when this 0 0, at that time these 0 will be high, remaining will be low. Similarly, when the 0 1, the combination will be 0 1. So at that time D1 will be high, remaining will be 0. And when the combination will be 1 0, So it D0 will be 0, D1 will be 0, D2 will be high and remaining will be 0. And when the combination will be 1, 1, so here this is will be 0, 0, 0 and 1. So here we can say this is very much similar to demultiplexer. So here you can see consistently in diagonal we are getting the 1, 1, 1. So for memorization you can remember this formula. In decoder we get the output in a diagonal form. Like suppose it will be 3 raised to 8 decoder, so here we get the 8 output D0 to D7 and we get the output in this manner. Suppose it will be 4 raised to 16 decoder, so here the input will be changed and output will be changed. So we get like this. Now when you will draw the diagram, so this is very much, as I told earlier, this is very much similar to demultiplexer. So here we get the 4 AND gates. Here we got the D0, D1, D2 and D3. So here we will give the inputs. You can give the input in a different manner. Suppose here I am giving the these are the two inputs A and B. So here I am giving, here I will take, in this way you can give the input. So here I am giving the 0, 0, it means A bar, B bar, 0, 0, A bar, B bar. So here we are, here when it will be 0, 0, so here we are getting the 1 and 0, 1. So 0 and 1, B is what? B is 1. So here I am giving like this. Now 1, 0, so this is 1 and this is 0 and 1, 1. So from this I can connect to this one as well as this one. This is another way to draw the circuit diagram. So this is 2 raised to circuit diagram of this is circuit diagram of 2 raised to 4 decoder. I hope this is understand to you, right? So this is 2 raised to 4 decoder. A decoder is also used in communication side. When we want to decode, at the receiver side, and encoder is used at the transmitter side. Thank you.